Today our lesson was on solving absolute value equations and inequalities. So when we talk about absolute value, first of all, what exactly are we talking about? So when we see absolute value, we know that it's something inside of these two little bars, right? And most of the time people remember about absolute value is that they're like, oh, it has to be positive. And that is true, but why? Why does it have to be positive? So when we're talking about absolute value, what we're really talking about is the distance from zero. Now, the key with distances, especially if you think about it on a number line, okay, the distance something can be from zero could be a positive number or it could be a negative number. However, the distance would remain the same. So for example, if you were driving a car and you're driving it forwards, right? You've maybe driven 4 miles, let's say, forwards. But what if you put your car in reverse and you drove backwards? Even though these negatives are representing the direction that you drove and you drove maybe backwards or in reverse, you still drove 4 miles. There's no such thing as driving negative 4 miles or something like that. So the negatives really represent the direction. So when we're talking about distance, there's never a negative distance, right? Like, could you measure your height and have a negative outcome? No. So distances are always positive. So when we see absolute value, we're really talking about, okay, what numbers have a distance from zero that's 5? So of course there's two options, okay? So 5, the number 5 has a distance of 5, right? And the number -5 also is 5 units away from zero, meaning it also has a distance of 5. So when we go to solve an absolute value problem, we have to remember that whatever's in those bars could have been 5 or whatever the number of units is away in one direction, or it could have been that same distance in the opposite direction. So even though it's not necessarily a negative distance, we have to account for the fact that there's two different directions that we could be measuring. So when we take a look at example 1 here, we want to account for the fact that whatever's in these bars here could be either equal to 5 or -5. So this x minus 2 here could be 5, because that would still come out as a 5, right? The reason it comes out as a 5 is because the number 5 is 5 units away from 0. This x minus 2 could also be equal to -5, because that's also 5 units away from 0 or has a distance of 0. So we have to figure out that this x minus 2 could be equal to the 5 right here from the first example, or x minus 2 could equal -5, because both of those are 5 units away from 0 or have a distance of 0. So that's why we have to set these up as two separate equations and then solve both of them. And we have two possible answers. The rest of it is just solving like you already know how to do. So we would add 2 to both sides, x equals 7. Over here, we would add 2 to both sides and get x equals -3. All right, so here's another example. So this time, it's going to equal 6. So this means whatever in these absolute values here, it could be 6, because the absolute value of 6 equals 6. But whatever, this 3x minus 1 here could also be -6, because that would also equal 6 or be 6 units away from 0 or have a distance of 6. So if I want to work this out here, I know that my 3x minus 1 here could be equal to +6, or my 3x minus 1 could be equal to -6, because both of those would equal 6 when we take them out of the absolute values. So that's why we're going to set this up two different ways. Now we're just going to solve them. So the first one here, we're going to add 1. 3x equals 7, divide by 3. We're going to get a fraction here. That is totally fine, 7 over 3. you wanted to write as 2 1/3, same thing. Then the other option here, we're adding 1 again. 3x equals -5. And we also happen to get a fraction answer for this one as well. Okay. Now the next two problems also have absolute values. However, there is something else in the problem. It's not just an absolute value with an equal sign and what it's equal to. There's also this like -5 in example C. In example D, there's this 2 out in front. So one of the general rules that we have to follow with absolute value equations or inequalities is we have to get that part in the bars all by itself. So before you can solve it, you'd have to get this 5 to go to the other side, and then you can combine it. So first thing we're going to do is move that 5 over. So now I have the absolute value of 2x minus 7 equals 9. Okay, so now again, this number in here, now that we have this equals 9 part, we know that the 2x minus 7 could be positive 9 because that would come out as a positive 9 or be 9 units away from 0. But the 2x minus 7 or whatever's in those absolute value bars could be equal to -9 because that would also equal 9. So again, we have to do this as two separate. So we could say, okay, the 2x minus 7 can equal 9. So I'm going to set that up. And my 2x minus 7 could also equal -9 because that would also work. So I have to do it that option as well. So now when I go to solve them, you're just doing the normal solving. So it's really that setup piece that's like the part you have to pay attention to. And then once you set it up, it's just solving a normal linear equation, just like you would have done back in Algebra 1. Okay, so there's our x equals 1 for that answer. And then if we finish solving out the other one, 2x equals 16 divided by 2, x equals 8. And there's our second answer. Okay, now example D, we also have a number on the outside of the absolute value bars. However, this one is not being added or subtracted. It's being multiplied to the absolute value. Now, one common mistake that people make is that they sometimes try to distribute, but you do not ever distribute a number to absolute values. Whatever's in the absolute value stays in there. Whatever's outside stays outside. So in order for us to get this 2 to go away, we would have to divide by 2, and whatever we do to one side, we would do to the other. So now we have x minus 3 equals 2. So that's kind of like our new problem now. Now, of course, this means that the absolute value of 2 can equal 2, but the absolute value of -2 also equals 2. So we're going to set this up with the two different options. Right? So we can do it this one and also this one. So x minus 3 could equal +2, or x minus 3 could equal -2, and either of those would come out of the absolute value as +2. So now we're adding the 3. So x equals 5 is one solution. Adding the 3 to the -2, and x equals 1 is your other solution. So now we're going to move on to these 3 examples here. I'm just going to go through them real quick. You might want to pause the video, practice, make sure you can do them, and then check your work. That's an option. If not, follow along. Okay, so x minus 4 equals 8. The other option is x minus 4 equals -8. Adding 4 to both sides, x equals 12. And the other one, we're going to add 4 to both sides again. X equals -4. Okay, example B. First, I got to move that 3 to the other side. So I'm going to make my new problem here, which is going to be the absolute value of 5x plus 1 equals 11. Now I can split it up into the two options. So 5x plus 1 might equal +11, but that 5x plus 1 inside there could also be equal to negative 11. Now we go ahead and solve the equations. So 5x equals 10, divide by 5, x equals 2. The other option, subtract 1, 5x equals negative 12, divide by 2, and x equals negative 12 over 5. Okay, and then our third example, which does not have any number that needs to move over to the other side. So we're simply just going to do the two options. 6x minus 4 could equal positive 2, or that 6x minus 4 inside there could also be equal to a negative 2, because both 2 and negative 2 would be the same distance from 0, just 2. So now we're solving them by adding the 4. 6x equals 6, divide. X equals 1 is one of my solutions. Adding the 4 to the negative 2 now gives me a 2. And then when I divide, I get x equals 1/3, because 2/6 simplified is 1/3. Okay, so moving on to the next page, we're now going to go over when we have an inequality sign in our absolute value problem, okay? So what's going to happen is when you had the equal sign, you just had to figure out the two different equations, and they're both at equal signs. So it really didn't matter. You're just getting two specific solutions, like x could equal 2 and x can equal 7 or whatever. They're just two separate numbers. But when we have an inequality sign, if you have a greater than, okay, so you can have a greater than or a greater than or equal to, either one of those. I always say it's going to be an or problem. And the cheesy way that I remember this is I say that it's greater. Okay, so anytime you have a greater than symbol, oh, and I wrote them backwards over here. I don't know what I'm thinking. So if you have a greater than or equal to, or even just like a greater than without the equal to, it doesn't matter. You're going to do an or problem, which means that you're going to kind of set it up the way we just did with the equal sign, but you're going to have to graph on the number line. That's that added piece. Okay, so it'll make a little more sense when I actually do one. Okay. So first thing you want to do is check and see, okay, what is my inequality? So my inequality here is a greater than sign. So we know it's going to be an or problem. Okay, before we actually can solve anything though, same rule applies here. We have to get the absolute value by itself. So we have the absolute value of 2x plus 1 is greater than or equal to the 9. Okay, so now the only difference comes in here. Whatever's in this absolute value, right, this 2x plus 1, if we were doing an equal sign, we would say it equals 9, and then we would write it again saying it equals -9, because it could be either one of those. They would have the same distance from 0. Same concept here, but we're going to do 2x plus 1 is greater than or equal to the 9. And then we're going to do 2x plus 1. And when we put the -9, we have to make sure we reverse the direction or flip the inequality sign. So it's the same thing we did with the equals, but we have to just make sure we flip that inequality sign for the negative version. Okay, then you would solve them each like you would solve any other inequality. So we would have 2x is greater than or equal to 8, divide by 2. We get x is greater than or equal to 4, or, and then we're going to do the other one. So now over here, I have 2x is less than or equal to -10. Divide by 2. X is less than or equal to -5. So my answer is x is greater than or equal to 4, or x is less than or equal to -5. Now you should already know how to graph this in the number line, because we spent the first 2 days prior to this doing inequalities with the graphing. So I always like to just kind of put a 0 in there if I have numbers on both sides. So my -5 would be somewhere over here on the left. My positive 4 would be somewhere over here on the right. I can see that both of these are going to be closed circles because of that equal to underneath the inequality sign. And x is greater than or equal to 4, so those numbers would be over here to the right. And this x is less than or equal to the -5, so those numbers would be on the left. Now, if you did this correctly, anytime you have an or problem, you remember my corny little thing, it's like you have oars. So the OAR oars, like the oars on a rowboat sticking out to the sides, that's what you should be looking for in your graph whenever you have an or problem. If it's not working out that way, you probably forgot to flip a sign or something like that. Okay, so let's do the next one. Okay, so this one here, first things first, we're going to move that 4 over to the other side. Doesn't matter if there's an equal sign, a greater than, a less than, you need to get this absolute value part all by itself to do anything. 10 plus 4 is 14. Okay, so now once we're done with that, since we don't have an equal sign, I have to look at my sign here and I have to see, is it a greater than or a less than? This is a greater sign. Remember, if it looks like an L, if you have it an L shape, then you know it's a less than. This is going the opposite direction, so we know it's a greater than sign. And that means that it's greater. Okay, so that's how I know what it's going to be. So now I'm going to do 3x minus 3 is greater than or equal to 14. So I'm pretty much just recopying it without the bars. Or 3x minus 3 is, flip the sign, less than or equal to negative 14. So when you do the negative version, you have to flip that inequality sign. Now we solve our two inequalities. Let's start by adding 3, dividing by 3, and I get x is greater than or equal to, you could leave it as 17/3, or if you write it as a mixed number, that would be 5 2/3. Or we're going to solve this one, see what we get. 3x is less than or equal to negative 11, and divide by 3. X is less than or equal to negative 11 over 3, or you could have negative 3 2/3. So that is my answer there. Now I'm going to have to put this in the number line. So the main reason why I put it into mixed numbers is because it's easier to plot on a number line. So if this is 1, 2, 3, 4, 5, 6, I would know that like my 5 2/3 would be somewhere around there. And it's going to be a closed circle, and x is greater than, so we're going out to the side. Then my other one, I have negative 1, negative 2, negative 3, negative 4. So negative 3 2/3 would be somewhere around here. Again, an closed circle, and then going out to the left because the less than numbers are to the left. Okay. So we're going to do 2 more of these. You can practice on your own. I'm just going to go through them real quick. Okay, first things first, we need to get the absolute value portion all by itself. So I'm going to add my 4 over. So now I have 5x plus 3 greater than or equal to 13. And because this is a greater than, it's an or problem once again. Okay, so I'm going to write it the 2 ways. I'm going to do 5x plus 3 is greater than or equal to 13, or 5x plus 3 is, flip the sign, less than or equal to, and then it's negative 13. So now we're solving. 5x is greater than or equal to 10. Divide by 5. X is greater than or equal to 2. Or, and on this side, I'm going to subtract 3. 5x is less than or equal to negative 16. And then that gives me a fraction. So x is less than or equal to, and that's going to be negative 3 1/5. And I don't care if you write it as a decimal or you leave it as the improper fraction, whatever helps you graph on the number line. Okay, so now if I'm going to graph that onto the number line, 0, 1, 2. So close circle at the 2, x is greater than or equal to 2. And then negative 1, 2, 3, 4, negative 3 1/5. That would also be a closed circle, and x is less than will go to the left. And again, my 2 arrows are going out to the sides, which is a good example of an OR problem. Okay, last one on this. See if I can enlarge it enough so you can see it well. Okay, so again, bringing that 4 over because we need to isolate this absolute value portion. So I have 5x minus 15 and then greater than or equal to 25. Obviously, we can see that that's a greater than, so this is going to be an OR problem once again. 5x minus 15 is greater than or equal to 25, or 5x minus 15 is, flip your sign, whoops, less than or equal to negative 25. So now I'm going to add my 15. So I get 5x is greater than or equal to 40. Divide by the 5, x is greater than or equal to 8. Or adding 15 over here, we get 5x is less than or equal to negative 10. And then when we divide, we get x is less than or equal to negative 2. So these are the answers for this one. And then we're going to put it on the number line. I have, let's say, a 0, negative 1, and negative 2. That's going to be a closed circle because of the equal to line, and x is less than would go to the left. Then 1, 2, 3, 4, 5, 6, 7, 8. Closed circle, and to the right. Okay, and then the last set of examples that we're going to go over, you might notice it looks almost the same, except this time you might notice that this is a less than sign. So if you have a less than or a less than or equal to sign, it's going to be an and problem like we did with the compound inequalities. And my corny way to remember this one is I write less than. So I know that's very corny, okay? But if I'm writing the word less than and I just add a D at the end of it, it says and. Whereas greater, if I just change the spelling, it's greater. That's how I remember that it's an or problem. The other way you could remember it is that your symbol kind of looks like an L, right? So that's how you know that it's a less than. But that's how I remember that it's an and. Okay, so again, first rule here, just like the equal signs, just like the greater or greater than or equal to signs, same thing applies here. You need to get the absolute value all by itself, isolated. So this little 7 here has got to go before you can do anything else. So now my problem is 3 plus x inside the absolute values is less than 3. Sorry. Let me fix that. Anyway, so now, because it's an and problem, I could write them separately and put an and in the middle, but that's just weird. Usually the and problems we want to write as like a 3-part inequality. So what we're going to do is we're going to take this part in the absolute value bars, and that's going to become the middle. And we're going to have our less than 3 on the right-hand side. It's always going to go on the right because it's the positive number. And then on the left, you're going to put another less than sign, so facing the exact same direction. We're not flipping the direction or anything. It's going to face the same direction as the one that we already have. And then we're going to put the negative version of that number there. And now we're just going to solve for that x in the middle. So remember, whatever you do to the middle on these, you do to both the left and the right. So we have 0 is less than x, which is less than Oops, I messed that up, sorry. -3 and -3 over here is just -6, sorry. So -6 is less than x, which is less than 0. Okay, now we graph and problems on the number line. -6, 5, 4, 3, 2, 1, 0. Both of these would be open circles, and our graphs for and problems should be shading in the middle. So as long as you have your smaller number on the left, your bigger number on the right, and your symbols are both less thans, it's going to shade in the middle of the two numbers. All right, so let's take a look at example B. Okay, so this one's nice because our absolute value is already isolated, so we don't have to worry about moving anything over. This we can see is a less than, right? So it's going to be an and problem. So when it's an and problem, when you see this less than sign here, your absolute value portion is going to go in the middle, so 10 minus 4x, less than or equal to 2. So that part stays exactly the same. But then on the left side, we put another less than or equal to. So remember, the signs are facing the same direction. And then I have to put a -2 on that side. So you always want those signs pointing towards the negative number or the smaller number and opening towards the bigger number. Once you have it set up as an and problem, we now solve for x. So subtracting that 10 from all three parts. So we have -12 is less than or equal to -4x is less than or equal to -8. Now we're dividing all three by -4. Now this is where it can get a little tricky because when you divide by the negative, those inequalities are going to change direction. So -12 divided by -4 is +3. The middle, you end up with x. And -8 divided by -4 is +2. Now, this answer is fine. You could leave it like that. But typically, if you're going to find this answer as a multiple choice or something, it would probably be written from least to greatest. So typically, we would see it written with the smaller number coming first, which is 2, the bigger number coming at the end or on the right side, which would be 3, and the x in the middle. Now, remember, the symbols always have to point to the smaller number. So 2 is smaller than 3. So both of these inequalities have to point the same direction, and they both have to point to the 2. Even when we wrote it this way, they were both pointing to the 2. So if you want to switch the order of it to make it easier to graph or to find your answer in a multiple choice or something, you need to make sure your signs are still pointing towards the smaller number. So now on our number line, if this is a 2 and this is a 3, they'll both be closed circles, and you still have to shade in the middle. Now what happens is sometimes when people do not rewrite their answer from least to greatest, they put numbers on their number line, like somebody might try to do this and put a 3 and then a 2, but obviously that does not make any sense. You can't put your numbers in backward order on your number line. So be really careful with that. It's like a common mistake that people make when they're kind of rushing through. All right, so we'll do 2 more of these examples. So for this one, we have that 8 that's on the same side as the absolute value. So we have to move that over first before we do anything else. So now I have 5x plus 1 is less than 24. So I see my little less than sign here. So I know that this is going to be rewritten as an and problem. So when I go to rewrite it, my 5x plus 1 is going to go in the middle. My less than 24 goes on the right, and another less than sign with a -24 all the way on the left. Now I'm solving for x by itself in the middle. Subtracting 1, -25 is less than 5x is less than 23. Dividing everything by 5. Now, this time we did not divide by a negative, it's a positive, so we don't have to flip our inequality signs. They're going to stay the same direction that they are. And that's going to work out perfectly because this here is 4 3/5, but it's positive. Over on the left, we have the negative, so obviously it's going from least to greatest. So our signs are correct. They're pointing to the -5 and they're opening up to that 4 3/5. Now we're just going to graph that on the number line. So let's just say this is 0 here. -1, 2, 3, 4, and -5. That's an open circle. Then 1, 2, 3, 4, 5. 4 3/5 would kind of be in the middle of those two. And that's another open circle. And then we're shading in the middle. All right, we're going to do one more of these. Okay, again, we have that 1 that needs to move away from the absolute value. So now my problem is the absolute value of 2x minus 5 is less than 7. Okay, so since I see this less than, I know this is an and problem. So I can write 2x minus 5 is less than 7. And on the other side here, I'm going to put the less than sign again with the -7. Now we're solving. Adding 5. So we have -2 is less than 2x, which is less than 12. Now we're dividing everything by +2. -1 is less than x, which is less than 6. The smaller numbers on the left, the bigger numbers on the right. The arrows are both pointing to the smaller number, opening to the bigger number. They're both less than signs, so we're in good shape. Now we're just going to plot this on the number line. -1, 0, 1, 2, 3, 4, 5, 6. Open circles at the -1 and the 6, and x is anything in the middle of those two numbers. Okay, so that is the end of our notes on solving and graphing absolute value inequalities and also solving absolute value equations.